So following on Governor Cox's remarks about the role that we are all need to play to help solve this minerals emergency, before I introduce our final speaker, I'm going to take a couple more minutes to highlight what SME can be doing in helping solve the minerals emergency. Just as Governor Cox said 2 minutes ago, SME members are a significant portion of the nation's mining and metallurgical brain trust. That's quite a responsibility if you think about it, because we have the mining, metallurgical, and other related technical expertise that is going to be absolutely essential in helping this country solve the minerals emergency. So what have we been doing to try to play our role in solving that emergency? Well, first and foremost, we have been committed to educating the next generation of mining professionals. Each year, the SME Educational Foundation awards millions in scholarships and has provided $20 million in scholarships to 12,000 students since 2019. SME's Minerals Education Coalition develops free materials for teachers who are teaching kindergarten through 12th grade can use to educate their students about the importance of mining and minerals in their everyday lives. And in a shameless plug for MEC, don't miss the poster that they've just developed in honor of the nation's 250th anniversary. This is a terrific poster that shows the minerals and metals and materials that were used to build the nation's monument. And you can take a look at the poster in the SME bookstore. SME has staunchly supported the nation's mining schools for many years, and in the past couple of years, we've been involved with efforts on Capitol Hill to try to enact the Mining Schools Act, which would provide additional funding to the nation's mining schools to help recruit more mining students who can become the next generation of mining professionals and to support some research. For many years, SME has recognized the serious problems that are stemming from Congress's decision 30 years ago to stop funding the U.S. Bureau of Mines. And we've taken the lead in informing policymakers that the U.S. needs a Bureau of Mines. In May of 2024, SME convened a roundtable of mining experts to discuss developing a new agency like the former U.S. Bureau of Mines. As a result of that roundtable, in September of 2024, SME published a concept paper entitled "Why the Nation Needs a National Materials and Minerals Council." And a key recommendation of that concept paper is that minerals and mining need to have an office within the executive office of the president. And last February, President Trump issued an executive order to create the National Energy Dominance Council. And we just heard from Governor Cox that he met with the President and the Secretary of Interior, Secretary of Energy, and he said the NEDC. Some of you might not have known what that acronym stands for. That's the National Energy Dominance Council. And remember, the word energy telegraphs energy and minerals. So needless to say, we're pretty pleased that it looks like one of the recommendations in that concept paper that we published last year, or in 2024, has essentially been realized with the creation of the NEDC. SME is constantly striving to establish the society as a source of mining and metallurgical processing expertise that policymakers like the NEDC, the President, the Secretary of the Interior, Dr. Mamula's boss, can rely on. And SME focuses much of that effort through what we call our Government and Public Affairs Committee, or GPAC. And I have the great honor of working with that committee as SME's government affairs consultant. The GPAC is meeting today over at the Hyatt from 1 to 3 in the Solitude Room. If you are interested in these kinds of policy issues, please consider getting involved in GPAC. We meet monthly on a virtual basis. We have a Teams meeting every second Wednesday of the month. So in closing, I want to emphasize that we have a once-in-a-career opportunity to advance domestic mining. You heard about that from Governor Cox. You heard the excitement in his voice about the broad recognition of the need for minerals and that this is the time to try to reduce our reliance on imports from China and other adversarial nations. So given that opportunity, it's appropriate to ask yourselves, what can I do to help solve the minerals emergency? Well, I'm going to make 2 suggestions for your consideration. First, although there is growing awareness that China's mineral dominance is threatening our national security, not everyone has read that memo yet, and not everyone understands the importance of mining and minerals. So when you can, take the opportunity to explain to family, friends, neighbors, and colleagues that minerals are the foundation of national and economic security and why we have a minerals emergency. Second, on a personal level, for those of us who are nearing retirement or at retirement age or even past retirement age, don't completely retire. Stay engaged. Yes, I'm looking at you, Dave. Because your expertise is more important than ever. And with that, I am going to introduce our final speaker. And it's really appropriate that our final speaker, Lucy England, is going to give the Robert E. Murray Innovation Lecture, because innovation is absolutely going to be critical in solving the minerals emergency and restoring America's mineral dominance. Lucy's presentation is entitled Sustainable Copper Mining Flowsheets and the MissionZero Mine, and she is presenting that on behalf of this year's award winner, FLS. Lucy is the head of capital sales, business development, and European sales. Until recently, she was the head of innovation at FLS, where they focused on MissionZero strategy for mining, specifically targeting emerging technologies to reduce emissions, energy consumption, and water usage for the green transition. As a minerals processing engineer from Camborne School of Mines, Lucy has dedicated over 26 years to the mining industry. Would you please join me in welcoming Lucy England?
Thank you. Well, hello, SME and MINEXCHANGE. It really is a pleasure to be here today, but I am slightly in awe of all of our speakers today, giving to you the Robert Murray Innovation Award on sustainable copper mining and the MissionZero flow sheet. So we're moving from mission critical to MissionZero now. The MissionZero strategy was launched in 2019, and we were really looking at a sustainability ambition to enable our mining customers towards zero water waste, zero emissions, and zero energy waste by 2030. And this not only inspired our R&D departments, this also inspired all of our colleagues around the world. And one of my favorite examples of this is the Clean and Green team that were formed in the community. And they were planting trees, and they were looking after these trees to stop soil erosion. And they also collected used and repaired and recycled equipment for the local communities. In addition to this, we were also producing, looking at ways to produce our own equipment in a much more sustainable way. And last year in Casablanca, in Chile, we opened up our LEED architecture mill liner facility. This reuses water, it's fully electric, and it uses 100% solar energy. So the mill liners produced in this facility are actually produced with 0 emissions. And then we had an R&D project over several years with a large consortium around the world on how do we recycle composite mill liners. Composite mill liners are really a bit of a problem because they're a landfill hazard. So in Chile, we were working with a miner, which I believe is actually Rio Tinto, recycling these mill liners. And we're running a pilot now that opened in 2025 from this technology we've developed, and it's successfully running at the moment. And we're hoping to roll that out across the world and hopefully into America. So you've heard several things about critical minerals, and I was really glad to hear that critical minerals include copper now and met coal, because we do need steel. And so we were really looking at how can we use our equipment to produce metals in a much sustainable way. And with the increase in demand of critical minerals that you've heard a lot about already in the talks today, how can we do that in a sustainable way and reduce our water footprint, our energy footprint, and our emissions footprint? So at MINExpo in 2021, we launched our MissionZero mine. Now this was born out of a miner coming to us and asking us in 2019 to look at all of the energy and water efficient technologies that we were developing at the time and putting them into a flow sheet. And then this flow sheet we developed, and this was the first MissionZero mine. So it was fairly conventional at the front end with gyratory crushing and secondary crushing. But then we were looking at novel comminution, so things like ore sorting, microwaves, electric pulses, feeding into dry grinding, and then into dynamic dry classification, and then into coarse flotation with our coarse flotation technologies, regrind into our reflux technologies, which are our new flotation technologies, and into a thickener filtration die stack system, and then thickener pneumopress concentrate system. So we're only taking this up to the concentrate at this point. But a couple of years ago, we acquired ThyssenKrupp Mining. And with that acquisition, we acquired some interesting technologies, one of which is the ERC, which is the eccentric roll crusher. Now, the eccentric roll crusher is quite interesting because it's kind of a mix between, and I'm not going to do the movement of the eccentric, but a gyratory crusher and I've lost my track now, a jaw crusher. What we can do with this is we can get higher reduction ratios, which is really interesting for heap leach applications because we can look at removing the secondary crushing station. And also very good for underground mining because you get a very good throughput, more like a gyratory, but it has a much smaller head height. And also we reduce energy with this system. And then we've got the HPGR. So we inherited the TK HPGR. Which is also already known for energy efficiency compared to sag milling if in hard ores. But we also introduced the HPGR Pro, which has rotating side plates, so you get a uniform material across the roll, so you reduce the edge effects. This actually increases our throughput. It increases our wear life, and it also increases the energy, reduces the energy consumption. And then if you combine the HPGR with a tower mill instead of a ball mill, you can significantly reduce energy in that combination. And you can also use the tower mill as a regrind mill in conjunction with coarse flotation. So out of Newcastle University in Australia, we we licensed the free flux technologies. And two of the newer technologies in this are coarse flotation and RSC flotation. We licensed this from Newcastle University when it was around a TRL 4. That's a technology readiness level of 4, and we've escalated that up to a technology readiness level of 8 to 9, where the RFC is now in production in a couple of places in the world. So the MissionZero approach was really about how can we develop efficient processing flow sheets using all of the new technologies to reduce energy, to reduce water, and to reduce emissions. And we were primarily focused on lithium, gold, iron ore, and copper. And one of the first things we did, and this isn't typical for lithium mining in America, and I do apologize about this, but we were looking at hard ores, so spodumene ores for lithium, and how can we produce those? So in 2019, we had a consortium where we were looking at a pyro island developed in Allentown, just south of New York, at FLS there, where we were looking at how can we reduce the energy or the gas in the calcination, the alpha to beta calcination of lithium. And we managed to put preheaters in, and then we put coolers in, and we recycled that energy around, reducing the energy. And then we did hydrogen firing tests, and we also did biofuels, and we looked at several ways of doing this. These pyro islands are now in production, one in Australia, one in Finland, and we successfully did that, but we're still using gas. But the reduction in gas was meaningful. So we then moved on to say, okay, we need to produce the 6% spodumene concentrate to feed this. So we developed a hard rock lithium flow sheet with stacked A-bond sizes with hardened teeth, dry grinding with our vertical roller mill, that was out of the cement industry. And then we were using next step flotation, which is conventional flotation with energy rotors, energy efficient rotors in, and then our reflux technology for the cleaners and recleaners afterwards. Going into thickeners without drives, which are our ECATs, and then filtered tailings. So we took all of this and we worked with Ore Minerals consultants and MissionZero to do an LCA and an LCC, which is a life cycle analysis and a life cycle cost comparison. And we compared that to a conventional flow sheet with wet tailings and dry tailings, compared to what we were calling at the time our shake-up study that we'll call our FLS flow sheet. And we did this on a gate-to-gate process, so this isn't cradle to grave, this is gate to gate for just this process. And we found that if we compared our flow sheet to the conventional wet flow sheet, we got a 16% lower climate change impact. We increased the life cycle cost by 3%, primarily because we were going from wet tailings to dry tailings. And then we increased the water, reduced the water scarcity by 15%, and we were using the AWARE process for that. And then if you compared it to the conventional flow sheet with the dry tailings, we reduced it by 21%, the climate change impact, 11% for the cost, the life cycle cost, and 11% for the water scarcity. So then if we move back to copper, which is where a lot of our work has been done, and this data is actually from the US Geological Society. We know that we need to produce more copper, and we've heard about that, so I'm not going to expand into that. But a lot of the copper that we produce is in water-scarce areas, so we really do need to consider the energy and water going forward. So we took some data on copper and gold mills from Ballantyne and Powell from the SEEK initiative in Australia, and we looked at where the energy was being used in the mine sites. And 0.2% of global energy is used in crushing and grinding for gold and copper ores. That's a significant amount. And when you take into account the amount of more copper that we've got to produce, that I haven't worked it out. Maybe somebody could calculate that for me. That is a significant amount of energy that we need. So we need to reduce the energy used in crushing and grinding. So what we did is we took a conventional flow sheet and we called the mill 100% energy. And then we started taking out bits of conventional equipment and replacing it with our new equipment. So we took out the gyratory crusher and we replaced it with an EIC, which gave us a 0.5% reduction. And then on our SAG mill, we put load IQ, that is an acoustic system with PSD control at the back end, and we could reduce it by a further 1.2%. But if we actually removed that SAG mill and replaced it with a HPGR, we could get an 18.5% reduction increase. So that really was the biggest change. So changing out a SAG mill on a very hard bond work index, by the way, this is a very hard composite low-grade ore, then you can get 18%. And then if we did our HPGR Pro upgrade, you could get a further 3%. And then if you changed out the bore mill for an FTM, you could get a further 5%. So that was great. So we looked at this, and then we looked at our coarse flotation. So we had to then change to a coarser grind. So we changed from a 150 grind, sorry if this is getting technical for some people, a 150 grind P80 to a 350 grind. But that means we had to, in our SciCAD simulation model, we had to rerun the whole thing. And once we rerun that and moved this grind size, we got a further 9.3% reduction. And then if you took out conventional flotation, you got another 2.3. So if you look around the whole flow sheet, we managed to reduce the energy just by putting our new technology in by 40%. But this was on a desktop study. We repeated this for dry grinding, and the results we got for dry grinding was 60% reduction. However, we were not confident in the dry grinding in terms of the classification for coarse flotation, which I'll take you through in a little bit. So then we dug in a little bit deeper, knowing that there's mines out there that maybe want to do brownfield upgrades and won't have full greenfield so they can start the mine planning from the beginning. So we looked at a conventional SAG ball circuit with fine grinding. And when I'm referring to fine grinding, it's not that fine. It's 150 that I'm referring to here. And then we changed that with coarse flotation and using the SAG ball circuit. And we managed to reduce the energy by 18%. But then if you went back to the fine grinding and took the SAG mill out and put a HPGR in, you could reduce it by 19%. And then if you did coarse flotation with HPGR ball circuit, you could reduce it by a further 34%. So following on from this, we decided that, okay, this is great at desktop study, but we really do need to do some test work on this and test each stage of the process, put it into a full engineering study, and look at the results. So one of the kind miners in America gave us 30 tons of very hard, competent ore, very low grade, and we used that. We collected a representative sample, we took it to a facility to cone and quarter, we dried it, and we shipped it to our R&D department in Salt Lake City here. We're out at Midvale. We have a large technology center out there. So we started looking at the simulations. We got the material in, and we pre-crushed it. We did metallurgical work on it, liberation work, to see what the grind size should be. And then we also did the pre-grinding. And then we developed two flow sheets that we were going to look at, which is the wet grinding flow sheet. So we had ERC going through to a conventional secondary grinding. We had the potential of ore sorting or novel comminution, like pre-treatment. And then we went into a HPGR FTM circuit, where the minus 150 micron went to straight to fine flotation, and the 150, 350 went to coarse flotation. So you weren't putting your fines through the coarse flotation. And then from there, we were looking for a throwaway tails. So really what we're trying to do here is make the large portion of our material being rejected to go into horizontal belt filter instead of pressure filter filtration to ease the dry stacking areas. And then we with the fine flotation, we had to go through a regrind, and then we had a standard thickener filtration. And we mixed the fine tailings with the coarse tailings to produce a more stable geotechnical stack. Pretty much the same for the dry grinding. The only difference is that we were looking at HPGR finish grinding here. So that's using a HPGR fully dry with a dynamic static classifier, because we were trying to produce two products, which hadn't been done before. So we're producing the grits from the static classifier and the fines from the dynamic classifier. And we were able to do this, although we had to adjust our grind size to be 250 and 100 for this particular flow sheet. So from Salt Lake City, we actually had to ship all the material for the HPGR grinding to Germany. We have a facility in Germany which is called a magro. I'm not sure why they call it a magro, they just do. So this is our magro in Aachen University facility, where we do HPGR grinding, but we had another facility that had the dynamic static classifier, which was only in Germany that we had to use. So we did all of the HPGR test work in Germany. We crushed it and then shipped it all the way back to Salt Lake City, which I know is not very sustainable, but yes, I'm also from England and I'm here in front of you today. So we worked with Wood Engineering on this project, and once we got all of this data together from the grinding and the regrinding and the flotation, we put it all into a full feasibility study to look at the impacts on energy. And interestingly enough, the wet grinding circuit came out as the most energy efficient. And this doesn't mean that dry grinding isn't efficient. It's just not efficient for coarse materials. With dry classification, you have big fans and you have air-swept material that go through it. And when you're trying to produce a 250 or a 350 grind, you have to use a lot of air to move that material. And that costs you a lot of money in energy. So, as you can see by the results, the wet grinding circuit, if you're using coarse flotation, not all materials are amenable to coarse flotation, then the wet grinding circuit is come out. And we really have to look at each mineral, its liberation size, what we have to grind to really develop these flow sheets. So this is just an example. But we reduced the energy in the comminution circuit. We I say slightly, about 40% reduction in the flotation circuit. And then obviously the regrind increased because we're using coarse flotation, so we have more material going through the regrind. And then the total installed power was about 40% less, very similar to our original study in the end. So then when we dug into the wet grinding, we looked at an SABC circuit, which is your sag ball circuit. We looked at HPGR ball circuit, and then an HPGR FTM circuit to look at the specific energies and where the energy was being used within each of the circuits. And as you can see, it's stepwise in energy reduction throughout. And this lines up with an OPEX comparison that we also did. So we took the sag ball circuit and we looked at all of the OPEX, and this was done in conjunction with Wood Engineering. So this is all of the ancillaries, all of the concrete, all of the steel structures were taken into consideration in this study, and the conveyor belts, before somebody asks about conveyor belts and HPGR grinding. So we looked at this, and it also worked in the same way, that by moving from SABC circuit to a HPGR ball circuit to a HPGR FTM circuit, you could reduce your OPEX through the years. So, in conclusion, environmental and economic benefits. By using new technologies, yes, we can really increase operational efficiency. And cost savings, yeah, being sustainable doesn't mean it's more expensive. It can be cheaper. If we're saving energy, we're saving money. If we're saving energy, renewable energy is more applicable. So yes, this is a way forward. And by reducing energy, we can also reduce our carbon footprint. So this is a miner from Cornwall. So I'm from Cornwall, from Camborne School of Mines. This is a tin miner from Cornwall. Previously, copper was mined in Cornwall. So in the town I grew up with, this is a statue of the miner. So I just have some acknowledgements. This was quite a large team across the whole globe working on this, primarily in our Salt Lake City facility, but obviously we had work in Germany as well. So Diane, Petra, Nico, Haji, Uwe, Yosha, Yako, and Wendy all need a very big acknowledgement for this work. And then I just wanted to leave you, finally, with the Wheal Basset mine. So as a child, I grew up in a mining district in Cornwall, which started out as a copper mining district, and when I grew up, it was a tin mining district. I went to Campbell School of Mines. I graduated in 1999. The last tin mine in Cornwall shut in 1998. So it was quite a bleak period in this area. So we really do need to think about how we look after our communities after mining leaves or when mining is approaching. But this is the Wheal, so we used to play down this. It used to be go play down the mines. I know that doesn't sound very politically correct these days. But this is the Wheal Basset mine, and this is a steam engine stamp. So this is the grinding that used to happen back in the 1870s. This was built. And this was just as the copper price was crashing in England at the time. And a lot of the miners that were working these stamps now moved to Salt Lake City and built new lives mining copper here today. So on that, I would just like to say thank you, and it's been a pleasure.